In this podcast, we're going to find out what scientists mean when they talk about work and energy. So, Ben, what actually is work?
Well, energy can be transferred and converted from one type to another in various different ways. Now, work, in the scientific sense, is the amount of energy transferred from one place to another using a force.
So if I push on something, am I doing work?
Not always. You're only going to do work if you actually move something against a force. So if you lift an object up against the force of gravity, or push something against the force of friction, then you've done work.
And how do I work out how much work I've done?
Well, the work is measured in joules, just like energy, and it's just the force times the distance that you move against the force.
So if I lift up, say, a 20 Newton ball by 2 metres, how much work have I done?
Well, then you'll have done 20 newtons times 2 metres, that's 40 joules of work, giving the ball gravitational potential energy. If you then let go of the ball, the force of gravity will do work on the ball as it falls, converting its gravitational potential energy into movement or kinetic energy.
So if anything moves against a force, does that mean work is being done?
Yes, that's right. So when you throw a ball in the air, you're converting chemical energy in your muscles into that gravitational potential energy of the ball.
And then what happens?
Well, then the ball falls back down under the force of gravity and hits the ground. It will deform, and the kinetic energy it had is converted into elastic potential energy. Then most of the elastic potential energy is converted back into kinetic energy again when the ball bounces back up.
So how much kinetic energy does an object moving like that have?
Well, it depends on the mass of the object and on how fast it's going. The kinetic energy of an object is equal to half of its mass times its velocity squared.
So if I throw, say, a 4-kilogram rock at 3 metres per second, how much kinetic energy would that have?
Well, the energy will be half of 4 kilograms times 3 squared, so 18 joules.
And if I throw it a bit faster, will it have more energy?
Yes, and because the energy equals the velocity squared, the energy increases much faster than the velocity does. This is why a car moving at 60 miles per hour has 4 times more energy than one moving at 30 miles an hour, and a crash at 60 is much, much worse.